Hey, this is Mark, and today I've got a couple of iPhone 7 Plus here for audio IC repair. So, as I'm sure a lot of you already know, audio IC repair is basically the new Touch IC repair. So I think it's probably been a while since I have uploaded a video about it. So I'll go ahead and just show you my approach. I'm sure that I have other videos on how to do this, but I'm also equally sure that in that time my approach has changed probably a few different times. I'm always willing to try out new techniques, modify what I'm doing slightly, see how it goes. So the way I'm doing it now, I tend to not have any issues at all with any kind of baseband problems. I do still see the baseband problems, but it's from like inheriting a audio IC job that's been somewhere else. So I know that kind of stuff is still going on out there in the micro soldering world. Although, I'm admittedly not as plugged in as I used to be. I just can't do Facebook anymore. Just can't. Can't handle that crap. All right, so now I use relatively high heat. So the actual temperature you set your station to is going to be different than what I set mine to. But really what you're looking for is for the chip to come off in less than 10 seconds. So yes, I'll say this, the temperature I'm using now for this particular job is about 40 to 50 degrees Celsius above what I normally use for other jobs when I'm working with the OEM lead-free solder. So I'm not a fan of throwing numbers out there because every station's different, and my 350 is going to be your 380, and your 400 is going to be my 380, and going to be the other guy's 350. So just kind of feel out your equipment and get it hotter than you normally use for other things. And you want the chips to come off in less than 10 seconds. And the idea there is, I guess I should point out that when I'm removing the chip, I'm using these hooked tweezers, right? They've got these little hooks that I've made. They hook underneath the edges of the chip, so I'm lifting the whole board up essentially by the chip. I'm holding the chip and the board drops away. And I'm using that high heat so that I heat the chip and the balls underneath it up really quickly. And it seems like that reduces the amount of heat that transfers through to the other side of the board, where you have your baseband CPU that you don't really want to disturb. So yeah, using those hook tweezers, high heat, get the chip off the board quickly, and then come in, just clean up all the pads. All right. Now I'm going to place my jumper, and I think probably by now anyone watching this is probably aware that the C12 pad is the one that tends to develop that fracture, just like the M1 pad in the 6 Plus Touch IC. Oh, gotta. Oh, there we go. Lost the pad. All right. Straighten that wire back out. Get it onto that resistor again. And we'll just leave the wire floating. So yeah, back to what I was saying. I suspect that most people watching this will already be aware of the C12 pad being the most common cause of the problem. But I've also seen enough times that this D12 pad has come off that that is now a standard part of my repair. I don't just address the D12 pad when it comes off. I do it every time. And the way that I address that, that's a PP1V8. I think it was PP1V8 SD RAM line. Maybe I'm wrong on that, but anyways, I'm sure it's a 1.8 line. And I've seen that pad come off often enough that I think it's worth doing every time, just as a preventative measure. And that same line connects to the chip in multiple spots, but this particular spot doesn't have continuity to other spots on the chip. So if you flip the chip over and probe between this pad and this pad, you won't have continuity, even though on the board you will have continuity between those two pads. And I don't see this. I think it's D, E, F, G, yeah, G12. I don't see G12 coming off. I've never seen it come off. So I just make this little jumper from G12 over to D12. And, I just feel like that's worth doing. I think I've seen enough D12 pads come off that I think it's worth spending the little bit of time it takes to do it. All right. That's one of the benefits of seeing just the kind of massive volume that we see of these is, it does get tedious doing the same job over and over and over, but it's really helpful at, identifying problems like that D12 pad being, a possible issue. It's not always going to come off, but after you do 100 of them and you have to place that jumper on 20 of them, yeah, maybe it's worth just doing it on all of them. It's a little bit of extra work. Not a big deal. So, got my jumpers placed on both boards. Now I'm just going to clean as much of the flux off as I can. Because these, at least for me, seem like these jumpers tend to shift as the chip's settling, more so than the M1 jumper on the iPhone 6 Plus Touch IC ever did. So I just always do the green UV curable solder mask available at iPad Rehab Supply. I need to get Jessa to set me up like a promo code so I get some kickbacks for for like the 5 people that will go and shop in our store because of watching my video rather than watching one of Jess's. I know there's like 5 of you out there. I think there was one time where we had a student who had like knew who I was but didn't know who Jessa was. And maybe I'm wrong. Maybe it's never happened, but I feel like there was one time where that happened, where there's like some international student that had like found out about us by watching my YouTube stuff and had just never like stumbled across Jess's. I don't know. Weird. All right. That's looking good. So just gonna set that to bake for a few minutes under the UV light while I reball these reball these audio ICs. That's what they are. Audio ICs. All right. Now I like to have a little paper towel in place while I do this. Just to kind of cushion the chip a little bit while I'm holding it down. And because it just gives it like a softer pad. I normally work on top of a cutting board, which is a little hard, so you can end up damaging your chips by putting too much pressure either while you're prepping them or while you're reballing them. Definitely time to cut the nails. I'm aware, YouTube, you don't need to go and tell me. I like having a little bit long to disconnect connectors, but let it go a little longer than I normally do. All right, so I am going to use a low temperature alloy. So this is some 138 solder paste that I'm using. Now, initially, I was kind of hesitant to use the 138. The guys in China like love this stuff. They use it for literally everything. But they also like they warranty things for like 3 months. So I know from personal experience, just from working with the stuff, that it is more brittle. Like that's just a fact. It's more brittle. Um, so I was legitimately concerned about how is this going to hold up over time. Um, so I did a couple of like batches of test phones where make a note that like I'm definitely using 138 on these 10 phones, and then you know give it a few months and see if we have any warranty stuff come back. And what I found is nope, nothing came back. So now I've started using it. I only use it uh, for the audio IC stuff, but I've not had a single case of something coming back with problems after using 138. So it does seem to hold up well, and it makes for a quicker getting in and out when I'm putting the chip back on, which is where the real risk is in overheating that baseband CPU. Because for removing the chip, the way that I'm doing it with the hook tweezers, really any temperature I use there that's hot enough is going to work, and not cause baseband problems. Um, but using this lower temperature alloy lets me, when I'm installing the chip, where I have to actually keep the heat on until the chip is settled and can't just have the board fly away as soon as the solder's melted. So for that kind of scenario, I've obviously got to keep the heat on there longer. I have no way to really tell if it's had enough time. So using this lower temperature alloy lets me kind of get in and out a lot quicker. So with this lower temperature alloy, I could also like lower my temperature way down and just use a lower temperature to put the chip on. But what I have found is that I get really good and consistent results with keeping it at that high heat, and with this type of low temperature solder, that high heat just quickly, like really quickly, seats the chip. So it's like I don't need to dwell on the chip and let the heat keep blowing on it after I see it shift like I would with leaded solder. I can just, as soon as I see that chip shift, get my hot air out of there, and I don't have to worry about whether or not it seated properly because all the solder melted or didn't melt, because I know with that high heat and this low temperature solder paste that the solder's definitely all melted as soon as I see that chip shift. So I had a couple of spots on this reball that I wasn't really happy with. So just kind of came back in, used my razor to cut the tops of all the balls off so that it was, the whole surface was flush and there wasn't balls sticking up. Reapply some paste and heat it up one more time, and we're done. All right, so we got both chips reballed. Got the UV mask on my boards cured. So now we're ready to come back in and stick these chips on. I do want to make sure I didn't get UV mask on the pads that I want to connect to the chip. So I'm just going to kind of poke at that. That's good. All right. Perfect reball. Let's see if I can, there we go. There's the mark for the A1 pin. All right, so we can just go in really quick and get it kind of stuck on there. Then come back in there, it's shifted into place. And, just not even a whole second after it shifts into place, just keep the heat on for, less than a second, and it just goes right where you want it to. All right, I think we're good on all the pads there. They're not covered up in green. I don't know if the microphone's picking it up, but my robot vacuum has started up, and man, I got the dumbest one that you can get. Like it doesn't like learn, so it just goes around the house like bouncing off of everything every night. It's funny. Like, you do a good job, bud, but you're not very smart. It's been the absolute best thing in the world for getting the kids to pick up their toys, like the small kids. Because now every night it's like, oh, well, you better pick your toys up or the robot's going to eat them. And no arguments, toys get picked up. No problem. If you have small children and your kids do not want to pick up at the end of the night, I highly recommend a robot vacuum. All right, so these should both be good to go now. Let's see. We'll give them a test. Hopefully this has a charged battery. Yes, it does. All right. And hopefully I have a passcode for it. Passcode says NA. All right. Well, I guess we will not be testing this one. Okay. All right, we're gonna chuck the other one in his housing. Hopefully we can test one of these. If not, well, I guess you'll just have to, oh, you know what? I looked at the wrong paperwork for that. I do have that passcode for that one. All right, we're going to go back to this one. I don't want to take a chance that the other one that says NA for the passcode actually has one. And I already know this battery is charged up. So we'll go back to this one. And I'm going to ask that if this one works, you just trust me the other one worked too. Because of course if it didn't work, I would just record another video and stitch them together. I think you know, we've got a rapport going. You can trust me by now. If you can't, then too bad. All right. So I like to test with the Voice Memos app. And yes, it is. It's recording. Yay, it's picking up audio. And it will play audio back. I think if I turn the volume up. Let's try that again. There we go. All right, so that is done. That's the way I'm doing audio ICs or now. I feel like it's pretty quick, pretty simple, and relatively risk-free if you know your equipment really well. So, you know, feel free to experiment with my methods and develop your own methods that work for you. So yeah, thanks for watching.